Hi guys, let's have a look at question number 14. So we've got a diagram, very complicated diagram, and we've got three right angle triangles. So ABC, ABC, so this one, ACD, ACD, and APD, APD. So those three right angle triangles. And it's giving us some measurements for AB, which is 4. So from here to there is 4. Then we've got BC, which is 3, and CD, which is 2. So all that's annotated on a drawing. Make sure you always check everything's already annotated. If not, annotate it yourself. And we want to work out the length of DP, so this one. Okay, so quite complicated looking diagram, and we are going to have to think about Pythagoras and about SOHCAHTOA, because these are the things we use in right angle triangles. It's a 5-mark question, by the way, so we're not going to be able to just get the answer straight away. But let's try to work out as much as we can. Okay, so in the base triangle, so in ABC, I see that I've got 2 measurements here, so that's the one I can start working with. So I've got the base, I've got AB, and I've got BC, and I can do a Pythagoras for it. I know that this is actually a Pythagorean triple triangle. So I know this side is going to be 5. You might want to go and check out Pythagorean triple right angle triangles. They're pretty cool. But if not, just do your Pythagoras as usual. So you can do that AC squared is equal to 3 squared plus, 4 squared. So that's 9 plus 16. That's 25. So this means AC is the square root of 25, which is 5. So I've got this AC or CA, and I've already labeled it. Let me put that in there as well. Now I can move on, and in triangle ACD, so in ACD, I can now work out DA or AD. And I'm going to do that by Pythagoras as well. So I'm going to say that dA squared. Again, it's a hypotenuse, so I'm going to be squaring and adding. So 2 squared plus 5 squared, that's 4 plus 25. That's the square root of 29. I'm not going to square root it just yet. So dA squared is equal to 29, but dA is equal to the square root of 29, like that. So in my calculator, I'm going to say square root of 29, which is 5.385. Okay, I don't want to round too much too soon. So for now, I'm going to say that dA is 5.385. So I've done everything I could do with Pythagoras. I don't have much information to do anything else using Pythagoras. So I would like some information in this triangle, in the last triangle, the one we haven't used. So in ADP or APD. And I would like to figure out some angles, right? So I can do a bit of SOHCAHTOA. So I'm going to start again with my small triangles. And I'm going to start again in this one in ABC. And I want to work out this angle here. So angle CAB. So if I want to work out angle CAB, if this is my target angle here, then I need to label the sides. So I know this one, CB is the opposite, and I know that BA or AB is the adjacent. So in my SOHCAHTOA, I'm going to write all that out. TOA. The one that has O and A in it is tan. So I'm going to be using tan, the tan ratio. I like to draw my triangle around it quite badly as usual. And I know that I need to work out tan of the angle here. I want the angle. So I know that this is what I'm looking for. I need to cover the T. So I'm going to do opposite over adjacent, but because I'm working out an angle, I'm going to do shift sign. So equals to tan minus 1 of opposite over adjacent. So the opposite is 3 over adjacent, which is 4. So I'm going to, in my calculator, type shift tan of 3/4. So 0.75. And I'm getting that one is 36.8698 something or other. And I'm going to do the same in my other triangle. So I'm going to go through the same process here in ACD. But this time I'm working on angle DAC. So angle DAC. And I'm going to use the same ratio, because if this is my target angle here, the purple one, then this means CD is the opposite, AC is the adjacent. So I'm using exactly the same ratio and the same process. So that's going to be inverse tan, so tan minus 1 of opposite, which is 2 over 5. I typed that in my calculator, so shift tan 2/5, and that's giving me 21.8014. So to work out the whole of angle A, so angle DAP, I'm going to add these together. So angle, so for this one, DAP is equal to that 36.8698 plus 21.8014. I'm just gonna add my first one, so 36.8698, and I'm getting the whole of that angle is 58.6712. Okay, great. So now I've got an angle in this triangle. So in DAP, and I've also got a side. So this means I can work out DP or PD. So I've got this angle here is my target angle, because that's the one that I know. That's that one. So I'm looking for this side, which is opposite in relationship to this angle. And the side that I worked out earlier, AD or DA, is the hypotenuse. So the trig ratio that has O and H in it is so. I build my triangle there, and I'm working out the opposite, so I cover the O. So this is telling me to do for DP, it's telling me to do sine of the angle, so sine of 58.6712 times the hypotenuse, because I'm going across. So the hypotenuse, I got it as 5.385. So in my calculator, I'm going to go sine 58.6712 close bracket times 5.385, and I'm getting an answer of 4.599 something, and that would round to 4.6, which is also the answer. Of course, it's centimeters. And that's it. That was a bit of a long one, 5 marks, but there you go. It's done. See you later.